have a midsegment that joins two midpoints. Okay, every triangle has three. Okay, which we talked about before, where we have, like, if all three of these are midpoints, I'd have a midsegment that goes here, a midsegment that goes here, and a midsegment that goes here. So every triangle has three. And the midsegment is parallel to the opposite side. So this line is parallel to this line. And then this length is half of this length. Okay. You do get something really interesting with the midsegment, so let me make a better version. Okay, let's say I have that triangle. And this is a midpoint, which means this length is the same as that length. And if this is a midpoint, then this length is the same as this length. And if this is a midpoint, then these lengths are the same. So far, okay? And then if I bring in midsegments, this is a midsegment. It's equal to half of this length, which makes it the same. So you get three segments, 1, 2, 3, that are all the same. And then if I bring in this midsegment, it's half of this length, so it's the same as each of these. And then if I bring in this midsegment, it's the same as each of those. So you end up with 3 line segments that are the same length. So it's kind of interesting little thing that happens. And what that gives you is a triangle that is like similar triangle. We haven't really talked about similarity, but similar is the same shape but a different size, proportional. This triangle right here is the same as this triangle here, except it's half as big and flipped upside down. So actually, you get 4 similar triangles. You would have to have, like if I knew this length, I could know this length, but I'd have to have some information. Like I would need to know like a coordinate for here so I could figure out going the right length, what the coordinates for the other side. You know, I'd have to have a little bit of information, but yeah, you could figure it out. Because you know it has to be parallel, so it has to be the same slope and then the same twice the length. Okay, so if I have that UV, that's this length right here, is 11. XV is half of that, because this is a midpoint, because it's a midsegment, so not 6.5, I lied, 5.5. 11 divided by 2 is not 6.5, 5.5. Likewise, let's say if xy is 13, I can find UW. So if this was 13, this is twice the length of that, 26. Good? Yeah? Okay. All right, so try these real quick, and then we'll go over them together. Put these on Tuesday. Because we're not going to have any more warm-ups this week, so we'll just do all these, and then I'll give you guys points. If we have a compound triangle, this is a midsegment, and I know that this is a midsegment because this is 10, and then this together is 10. So 8 is a midsegment, this length here, and then X is also a mid-segment because these are both 5s and these are both 6s. Okay, so I have a mid-segment and then a mid-segment of the new triangle. So if 8 is a mid-segment to the whole big triangle, that makes Y 16. Because Y will be twice this mid-segment. And then x is the mid-segment to the small triangle, which would make that half of 8, because 8 is the bottom of the small triangle. So that would make x 4. And a triangle can have, not in the bottom half, but in the top half. You can just keep doing mid-segment, mid-segment, mid-segment until you run out of numbers to cut in half. Like I could have another one here at 3 and 2.5, and then I could have one at 1.5 and 1.75. You know what I mean? Like I could keep going smaller and smaller and smaller until I run out of room. No, Pascal's triangle is related to exponents. It does kind of work similarly as far as the look of it, but when you make Pascal's triangle, you've got like this. And what happens is if I'm multiplying polynomials together, squaring them, and these are the exponents that I get. Or not the exponents, sorry, the coefficients that I get. Not exponents, coefficients. Never use it. I used to always do it the long way. We're going to skip this one because we just did all those. Okay, now we have angle inequalities. Now we talked about before where we had an exterior angle. So if this is 1, 2, and 3, angle 3 is equal to angle 1 plus angle 2. Remember that? That is what brings us to the exterior angle inequality theorem, which tells me if I have a triangle with an exterior angle, angle 1, angle 2, and angle 3, because angle 3 is equal to angle 1 plus angle 2, angle 3 has to be greater than angle 1, and angle 3 has to be greater than angle 2. If it's the sum of the two, it has to be bigger than both of them, because angles can't be negative. So that's what the exterior angle inequality theorem just tells me, is that any exterior angle is bigger than the two angles on the opposite side of the triangle. Individually, not together. It's equal to them together, but individually it's greater than them. And then we have, if we have another triangle, okay, and we will call this x and y, and we will call this a and b. If y is greater than x, then a is greater than b. Okay, so the wider angle is across from the bigger side. And it makes sense, right? Because the wider angle is going to open up further, so the side on the other side would be longer. And then the smaller angle is across from the shorter side. Does that make sense? And then if one angle of a triangle is larger than another, didn't I just do that? Oh, sorry, I drew that arrow the wrong way. I need to go this way. This is the longer sides make the bigger angles. And then if we come over here, we get the bigger angle makes the bigger side. Oops. So if this is x, and this is y, and this is a, and this is b, if x is greater than y, then b will be greater than a. So this is just same thing, just going the opposite direction. Before, longer side across from the larger angle. Here, larger angle across from the longest side. Does that make sense? So here we're doing sides, angles lead to sides. And there we did sides led to angles. So far okay? Then we have the triangle inequality theorem. So if I have this triangle, and this side is A, and this side is B, and that side is C. Okay. A plus B has to be greater than C. A plus C has to be greater than B, and B plus C has to be greater than A. And here's why. If I have, let me get lines. Okay, here is one side of a triangle. And here is another side. And here is the final side. Okay. If I then take those triangle sides, if I can select it, and I collapse them down and make them flat, they're going to overlap. Do you see that, how they're going to overlap? If they don't overlap, if they are even just the same length as the third side, and I bring them up without extending them, there is no way for them to connect and make a triangle. So two sides have to be bigger than the third side always. Does that make sense? Okay. Then we have the side angle side inequality theorem. This is when we have two triangles. So let's do two triangles. Only we'll do it not green. Okay, so I have two triangles, let's just say. Try to make them the same side. Okay. If two sides of one triangle are congruent to two sides of another triangle, so what I have is, let's say this side is the same length as that side, and this side is the same length as this side, but we'll say angle A and B, we'll say angle B is greater than angle A, then the third side of the one triangle will be bigger than the third side of the other triangle. Which is kind of the same thing as when we talked about just a second ago where the biggest angle is across from the biggest side. That still holds true here. If these two sides are the same, but then this angle is bigger than that angle, that means this side is going to be bigger than that side because it just opened up further. Some people also call this like a hinge theorem, because if the hinge opens up further, the third side is the longer. Okay, and then we have side, side, side inequalities. So if I have two triangles, and this side is the same as that side, this side is the same as this side, but then A is greater than B, so the third sides are not equal, then this is X and this is Y. X will be bigger than Y. So the angle opposite the larger triangle side will be the larger angle. So far okay? So, can the following be lengths of the sides of a triangle? In order to be lengths of the sides of the triangle, two always have to be greater than the third one. So to check, you say, okay, is 3 plus 4 greater than 5? Yep. Is 3 plus 5 greater than 4? Yep. Is 5 plus 4 greater than 3? Yes. So yes, can be. Yep. Okay. Now, do you have to do all three of them? No. If you take the two smallest sides and they're greater than the third side, you're good. Yeah. Because if you think about it, if the two smaller sides are greater than the third side, then the third side plus either of those will be bigger than the next one. So you just add together the two smallest, make sure they're bigger than the third one, and yes, it could be a triangle. Does that mean it is? We don't know, but it could be. So far okay? Identify the largest angle. Well, we look at the three sides. Here's the biggest side. The biggest side is across from the biggest angle. So angle B. Identify the shortest side. I first need to find out what is this missing angle. So I'm going to take 180 minus 59 and minus 58 and determine what that angle is. And that angle is 63. Now I know all three angles. I come back and I say, okay, I want the shortest side. I find the smallest angle, which is 58, and it is going to be across from the shortest side, which is MO. So the shortest side would be MO. The longest side would be across from 63. And the middle side would be across from 59. Okay. Which side is longer, AB or BC? Well, I'm looking for AB and BC. I know that these two sides here are the same length, which means this is 46, which makes this also 46. Okay, this isosceles, the big triangle. I need to find out what this missing angle is. So I have 46 and 46 and 51, so I need to find this missing angle. So I'm going to take 180, the whole big triangle, and subtract the two 46s and the 51. And that'll tell me what this missing piece is, which is 37. Okay. So now 51 is across from AB, 37 is across from BC. So which side is longer? The one across from the bigger angle, so 51, so AB is longer than BC. So far okay? And then which angle is larger, angle 1 or angle 2? 16 is bigger than 15 and it is across from angle 1. So that makes angle 1 larger. The practice test.